So the next concept that we will take a look at is making equations. This is a very important concept because you can solve practically any question of time and distance if you understand this concept very well. So let us see what this concept exactly is. So we have distance is equal to speed into time. There are three variables here. The first one is distance, the second is speed, and the third is time. So how do you make an equation? My experience tells me that most of the equations in time and distance can be made by equating either of the following. Number one, the total distance, or the total time, or the difference of time. Now, if you know how to use these three variables very well, you will very easily create equations which will help you solve any question on time and distance. Well, let us solve a few questions, and only solving questions can help you understand what I'm trying to convey here to all of you. So here comes the first question. A man travels from Bhopal to Indore and back in 7 hours. He traveled to Indore in a Volvo bus at an average speed of 75 kilometers per hour. He came back by train at an average speed of 90 kilometers per hour. He spent 30 minutes at Indore in completing the tasks assigned to him. What is the distance from Bhopal to Indore? So, so let us understand that by a schematic representation. We have B, that is Bhopal, and here we have I, that is Indore. And since the distance between Bhopal and Indore is not known to us, we assume the distance to be D. Now, what should you equate from the given information in this question? If you carefully look, you'll find that the total time has been given. Because this person travels to Indore at 75 kilometers per hour, he comes back at 90 kilometers per hour, and at Indore he spends 30 minutes. So total time for all these three activities has been given as 7 hours. So how did we spend this 7 hours? The total time? The total time has been spent in going from Bhopal to Indore, represented by TBI, plus in coming back from Indore to Bhopal, represented by TIB, and there is a third component, that is 30 minutes, which has been spent in tasks assigned at Indore. Now, if you see this equation, we can replace time, that is TBI plus TIB, by distance divided by speed. Let us do that. Total time TBI is equal to D by 75 because the speed of going to Indore was 75 kilometers per hour, plus TIB, that is D by 90. So distance divided by 90 kilometers per hour, plus 30 minutes that have been spent in accomplishing the tasks. So you rewrite the equation. 7 hours is equal to D by 75 plus D by 90 plus 30 minutes, which can be looked at as half an hour. And if you solve the equation for D, you will get D is equal to 450 into 6.5 divided by 11, that is roughly equal to 266 kilometers. So you saw how we utilized the concept in this question. We equated the total time and we said the total time was spent in the two segments, the segment of going and segment of coming back, plus performing the tasks assigned at Indore. Let us look at another similar question and see whether the concept is applicable even there. A man travels one third of the distance at 20 km per hour, another one third at 30 km per hour, and the final one third at 40 km per hour. Find the total distance covered when the total time taken for the entire distance is 4 hours. Again, what should we equate in this question? We see that from A to B, the total distance is d, as you can see there. And this total distance is divided into three segments. Each segment is 1/3 of the total distance, d by 3, d by 3 and d by 3. Now the total time has been spent in each of these three segments. So in the three segments, the person has moved at 20, 30 and 40 km per hour respectively. So what is our basic equation? Total time is equal to T1 plus T2 plus T3, which are the times required in the first, second and the third segment respectively. Now replace time in the above equation by distance divided by speed for each of the segments. So what do you get? Total time is d by 3 upon 20, which is the time required in the first segment, T1. Then T2, that is the time required in the second segment, is d by 3 divided by 30. And finally T3, which is the time required in segment 3, must be d by 3 upon 40. Rewriting the above equation, we have 4 hours, which is the total time, is equal to d by 60 plus d by 90 plus d by 120. On solving this, we get d is equal to 360 into 4 divided by 13. So let us take a look at another example which we can solve using the same concept. A man covers 400 km from Bhopal to Nagpur in 8 hours. He travelled a distance of Bhopal to Baitul by train at an average speed of 80 km per hour, whereas he travelled the rest of the distance by bus at 40 km per hour. Find the distance of Bhopal to Baitul. Again, we start with a schematic representation. In fact, in time and distance, it is a good idea to start with a schematic representation, as that helps you analyze the problem better. And this is especially so if you are new to solving questions of time and distance. So we represent Bhopal by the letter B and Nagpur by the letter N and Baitul by BT, as you can see there. The distance between Bhopal and Baitul is represented by D, and obviously the remaining distance between Baitul and Nagpur will be 400 minus D, because the total distance from Bhopal to Nagpur is 400. So 400 minus D. Next, what do you equate now? If you see this question, you have both total distance as well as the total time. And according to our concept, we could equate either the total distance or the total time. First of all, let us equate the total time and see. But before that, how many segments are there here? There are two segments here, the segment of 80 km per hour and the segment in which this man travels at 40 km per hour. So our total time is equal to T1 plus T2, the time required in the first and the time required in the second segment. So 8 hours, which is the total time, is equal to T1 can be replaced by d by 80, the time required in the first segment, plus T2 can be replaced by 400 minus d upon 40, which is the time required for the second segment. So 8 is equal to d by 80 plus 2 into 400 minus d by 80, which is nothing but rewritten form of the above equation. On solving for d, we will find the value of d to be 160. Let us see if we can also solve the above question by equating the total distance. Again, the same schematic diagram. The distance between Bhopal and Baitul is now taken as d1, and the distance between Baitul and Nagpur is taken as d2. Obviously, the total distance will be equal to d1 plus d2. There is no question of any issue here. 400 is equal to S1 T1, where S1 is the speed in the segment D1 and T1 is the time traveled during the segment D1. Similarly, D2 is equal to S2 into T2, where S2 and T2 are the speed and the time required in the second segment. So 400 is equal to 80 into t plus 40 into 8 minus t, because if you assume the time for the first segment to be t, obviously the time for the second segment should be the total time 8 minus t. So on solving this, we have t is equal to 2 hours. But we are not only required to find the time traveled to Baitul, but we are required to find the distance of Bhopal from Baitul. And the distance d1 can be calculated as speed 80 km per hour into the time, that is 2 hours, and therefore the distance is equal to 160 kilometer per hour. 160 kilometer. So which equation should we use in solving the above question? Should we equate the total distance or should we equate the total time? Obviously, the answer lies in what has been asked. If you look at the equations carefully, the first equation where you equated the total time straight away gave you the distance. So if you are asked to calculate the total distance, the first equation will be superior. Whereas if you are asked to calculate the time traveled from Bhopal to Baitul, then the equation where you equate the total distance is a better solution. So with this, we come to an end of this part of time and distance. If you have any feedback or if you have any query, please feel free to mail us at studentservices@pfindia.com. Thank you.